आदर्श शिंदे, आदर्श शिंदे, आदर्श शिंदे, अंकिता, चंद्रशेखर,
Present, sir.
ओके, हर्षगौड़ा, हर्षगौड़ा, जानवी, जानवी, महादेव, मोहम्मद, कीर्ति, कीर्ति, पिकेश, रोल नंबर 11, 12, 13,
Present, sir.
14, ओके, 14, 15, 16, 17, 18,
Present, sir.
okay, 19,
Present, sir.
right, 20,
Present, sir.
right, 21, 22, 23, 24,
Yes, sir.
okay, 25, 26, 26, 27, 28,
Present, sir.
Present, sir.
okay, 29, 30, 31, 32, 33, 34, 35, Manjunath, 36, Pratmesh, Joslino, Soham, Atiya,
Yes.
okay. In the last class, we were discussing about the feedback amplifier.
Excuse me.
Yes, tell me.
Sir,
The roll number
27.
15 present, sir.
Roll number? I have marked
15, sir.
yours. I have marked yours.
Yes, sir.
Sir, roll number 27.
I have marked. I have marked. Let us look at the voltage shunt feedback amplifier. We will derive the equation for its input impedance of voltage shunt feedback amplifier. Are you able to see the screen? Screen is visible?
Yes, sir.
Okay. So this is the voltage shunt feedback amplifier, right? If we look at the basic circuit of voltage shunt feedback amplifier, then this is the voltage shunt feedback amplifier. We have the input current source Is, right? A is equal to V naught by II, and there is V naught at the output across RL. Beta is equal to IF by V naught. Beta is equal to IF by V naught, or IF is equal to beta V naught. That is voltage shunt feedback amplifier means the output voltage is collected from the output terminals, right, and applied as input to the feedback. The output of the feedback circuit is applied in shunt or in parallel. The output of the feedback circuit is applied in shunt or in parallel with the input current source. Okay, this is the meaning of voltage shunt feedback amplifier. So we have voltage shunt feedback amplifier. The input current source Is, II, Ri is the input resistance. Aii is the output voltage. V naught is equal to Aii because we have A is equal to V naught by, right? A is equal to V naught by II, or V naught is equal to Aii. We look back at the voltage shunt feedback amplifier, A is given by, that is gain without feedback is given by V0 by II, or V0 is equal to A into II. Then output resistance is R0 in series with the voltage source. Then we have the load resistance RL. The output is taken, right, and it is applied as input to the feedback circuit. The output of the feedback circuit is the current, because it is applied in shunt with the current source. It is the output current we are getting here. Okay, output current from the feedback. Then input is the voltage. Therefore, we have beta is equal to IF by V0. Beta is equal to IF divided by V0 is the, that is feedback factor, feedback gain. It is IF by V0. Now here we have to derive the equation for the input impedance of voltage shunt feedback amplifier. That is, with feedback, what is the input impedance? ZIF is given by VI. VI is the input voltage across here, across RI. Then the current at the input, that is source current, is IS, right? This is the input impedance with feedback. If we want the impedance without feedback, it is simply VI by II. VI divided by II, that gives without feedback, because the feedback is applied to the current source. Therefore, if we consider VI by IS, it is the input impedance with feedback. Okay, that is VI divided by IS is what? IS is equal to II plus IF. This current IS is getting split as II plus IF. That is, IS is equal to II plus IF. Write it as II plus IF. That is further equal to VI divided by II. Then IF is beta V0. That is, here beta is equal to IF divided by V0. IF is the output, input is V0, or IF is equal to beta V0 for the voltage shunt feedback amplifier. IF is equal to beta V0. That is, substitute IF as beta V0. That is, divide further by II, the numerator and the denominator. Divide the numerator and denominator by the current II. We get VI by II, that divided by II by II plus beta V0 by II. We are dividing the numerator and the denominator by II. Once we divide the numerator and the denominator by II, then we get ZIF is equal to VI by II is the input impedance without feedback. VI is the input voltage across voltage. II is the current which is entering into the resistance RI. VI by II gives the impedance at the input terminals without feedback. Okay, that is ZI. VI by II is ZI without feedback input impedance. That divided by II is 1 plus beta. What is V0 by II? V0 by I told just now. A is equal to V0 by II. A is equal to V0 by II. Right? If you look back at the voltage shunt feedback amplifier here, right? So this is voltage shunt feedback amplifier. A is equal to V0 by II, or V0 is equal to A into II. V0 is equal to A into II. Right? So V0 by II is equal to A, or V0 is equal to AII. We are substituting V0 by II as A, then we get ZIF is equal to ZI divided by 1 plus beta A. ZI divided by 1 plus beta A. This input impedance with feedback is less than the ZI, because it is ZI divided by 1 plus beta A. Beta A is 1 plus beta A is greater than 1. Suppose if you take ZI as say 10, then 1 plus beta A, suppose I am giving an example, 10 divided by 2, that will be 5. Okay, so ZIF will be 5, ZI is 10. So ZIF is less than ZI. ZIF is input impedance with feedback is less than the input impedance without feedback for the voltage shunt feedback amplifier. So for the voltage shunt feedback amplifier, what is the input impedance with feedback we are getting? It is ZI divided by 1 plus A beta. Okay. So you all understood the derivation here? Derivation is clear? Everyone understood the derivation? Any doubts in this? Atya, any doubts? Atya? Shubham?
Yes, sir.
Any doubt, Shubham?
No, sir.
Okay, fine. We'll proceed with an example on voltage series feedback amplifier. Note down this example. Determine the voltage gain, input and output impedance with feedback for voltage series feedback having A is equal to minus 100, Ri is equal to 10K and R not equal to 20K for feedback of first one beta is minus 0.1 and beta is minus 0.5. The question is like this: determine the voltage gain. First one you have to find the voltage gain A value, input impedance Zi and output impedance Z0. It is with feedback. If it is with feedback, then A will be A of Zi, input impedance will be Zif, and output impedance Z0 will be Z0F. Z0F. For voltage series feedback amplifier, the gain is given A value, gain without feedback. This is gain without feedback. A is equal to minus 100, and Ri is nothing but the Zi without feedback. It is 10K, and R0 is nothing but Z0. It is without feedback, that is 20K. And beta values are given. For the first one, beta is minus 0.1, and for the second one, beta equal to minus 0.5. Okay, we have to use the equations and solve for the voltage series feedback amplifier. They are given it as voltage series feedback amplifier. The same question may be asked for voltage shunt feedback amplifier, right? Then you have to use the equations of voltage shunt feedback amplifier and you have to solve it. Okay, let us solve this. Using the equations, we obtain AF is equal to, what is the equation for gain with feedback? It is A divided by 1 plus beta A. Gain with feedback for voltage series feedback amplifier is given by A divided by 1 plus beta A. Substitute the values. A value is given, it is minus 100. That divided by 1 plus beta value is how much? Minus 0.1 into A value is minus 100. A value is minus 100. Simplify this and tell me how much you are getting. A divided by 1 plus beta A. Did you all note down the example? Note down the example and we'll solve it.
So minus 9.09.
Minus 9.09. Okay. How much is 100 into 0.1? 100 into 0.1 is how much? How much you're getting 100 into 0.1?
So 10.
Very good. It is 10. Minus into minus is plus. So 100 into 0.1, the shift by one decimal place. So 100 into 0.1 is 10. Okay, with minus into minus is plus. So 1 plus 10 is 11. That will be minus 100 by 11. That is equal to minus 9.09. Fine. Next, find out input impedance with feedback. That is Zif is equal to Zi into 1 plus beta A. The equation is Zif is equal to Zi into 1 plus beta A. Substitute the values and find out. Zif is equal to Zi into 1 plus beta A is the formula. Tell me the answer, how much you are getting. Zif is equal to Zi into 1 plus beta A. Zi is the input impedance without feedback, right? A is the voltage gain without feedback and beta is the feedback factor. Feedback factor or feedback factor beta is given. Substitute these values and find the value of Zif. How much you are getting? What is the answer, students? Zi into 1 plus A beta. How much are you getting, students? Are you getting 110K? Zi into 1 plus beta A. Zi is given 10K, right? Ri is nothing but Zi, that is 10K. That into 1 plus beta A. Beta is minus 0.1 into A, that is 100, minus 100. Okay, that will be equal to 110K. So 1 plus beta A, 1 plus minus 0.1 into minus 100, that will be 1 plus 10, that will be 11. 10K into 11, that will be 110K. Are you getting the answer? For voltage series feedback, yes? Getting the answer? For voltage series feedback amplifier, it is Zi into 1 plus beta A. For voltage shunt feedback amplifier, it is ZIF is equal to Zi divided by 1 plus beta A. Remember, the ZIF formula for voltage series feedback is Zi into 1 plus beta A. For voltage shunt feedback amplifier, it is ZIF is equal to Zi divided by 1 plus beta A. Next, for the voltage series feedback amplifier, ZOF, that is Z0 F, is given by Z0 divided by 1 plus beta A. Z0 divided by 1 plus beta A. Substitute the values and find the value of ZOF. That is output impedance with feedback. That will be Z0 divided by 1 plus beta A. Find out how much you are getting. Z0 F, output impedance with feedback, is Z0 divided by 1 plus beta A.
Sir, 1.81 K.
1.81
K.
K, correct. Approximately 1.82 K kilo ohms, right? It will be 1.82 kilo ohms. Fine. Similarly, next for the second part of the example, beta is equal to minus 0.5. Find out the values of AF, ZIF and Z0F. For the second one, beta is equal to minus 0.5. Tell me the values of AF. Formula remains the same. Find the value of AF, ZIF and Z0F. And tell me the values. How much you're getting?
Sir, minus 1.96.
Okay, what about ZIF?
IF is 510 K.
ZOF? Z0F? How much you're getting? Z0F?
So 400.
Okay, let us check. AF, it is A divided by 1 plus beta A. A is minus 100 divided by 1 plus minus 0.5 into minus 100. Beta is minus 0.5 for the second part. Minus 0.5 into minus 100 is how much? 0.5 into 100. It is how much? 50, right? Minus into minus is plus. 50 plus 1 is 51. It is minus 100 divided by 51. That we get it as minus 1.96. Okay, AF, that is gain with feedback. Then second one is input impedance with feedback, ZIF. That will be ZI into 1 plus beta A. ZI into 1 plus beta A. This will be how much? ZI is 10K. Then 1 plus beta A is 51, as we have got here. 10K into 51. It will be 510K. 510K. Then output impedance with feedback will be Z0 divided by 1 plus beta A. That is equal to 20 into 10 raised to 3. That divided by 1 plus beta A is 51. If we divide these two, then we get 392.16. Okay, this is the output impedance with feedback. Output impedance with feedback. All of you are getting these values here? Yes? All the students are getting these values? Chandrasekhar,
Yes, sir.
getting the values. Chandrasekhar, answers.
Yes, sir.
Chandrasekhar.
Sir, beta value 0.5 ರೀ. ಅದ 0.5 ರೀ. ZOF ಏನ್ ಬರ್ತದೆ ಸರ್?
0.5 beta value 0.5 ಐತ್ರಿ. 0.5 into A ಮಾಡ್ರಿ. 0.5 A value 100 ಸೇಮ್ ಇರ್ತೈತ್ರಿ. ಅದೇನ್ ಚೇಂಜ್ ಆಗಂಗಿಲ್ರಿ. A value ಸೇಮ್ ಐತ್ರಿ, 100 ಐತ್ರಿ. ಗೊತ್ತಾತಿಲ್ರಿ?
ಹಾ ರೀ.
A value 100 ಐತ್ರಿ, beta 0.5 ಐತ್ರಿ. 0.5 into 100 ಎಷ್ಟು ಬರ್ತೈತ್ರಿ? 0.5 into 100 is 50. Is it not? 0.5 into 100 is 50. Shift by one decimal place. So it will be 50. Then minus into minus is plus. 50 plus 1 is 51. Yes or no?
Yes, sir.
Your doubt is clear? Okay.
Yes, sir. Clear, sir.
Fine. Ratan, solve the example. Ratan, Birje.
Yes, sir.
Ratan, getting these values, answers?
Yes, sir. Yes.
Okay, fine. Sagar, getting the values, Sagar? Samir Ahmed,
Yes, sir.
getting answers, Samir Ahmed?
Yes, sir.
Any doubts here?
No, sir.
Okay. Sanket?
Yes. Yes, sir.
Any doubts, Sanket?
No, sir.
Any doubts here? Okay. Okay, then we'll proceed with the next topic. Current series feedback amplifier. We are deriving the equation for the output impedance of the current series feedback amplifier. Let us see the basic circuit of current series feedback amplifier. This is the current series feedback amplifier. The output current, the current from the output is tapped as input to the feedback. Current from the output is tapped as input to the feedback circuit. Okay. The output of the feedback circuit is the voltage. Output of the feedback circuit is the voltage which is applied in series with the input. Output of the feedback circuit is the voltage is applied in series with the input. Okay. This is called as current series feedback amplifier. Output of the feedback is voltage, input is the current. Then the gain, forward gain or the gain of the amplifier is A is equal to I naught by Vi. Output is the current, input is the voltage Vi. A is equal to I naught by Vi. A is equal to I naught by Vi. Okay. This is the current series feedback amplifier. Keep this in mind. A is equal to I naught by Vi or I naught is equal to AVI. I naught is equal to AVI. Okay. We are drawing the circuit here. Vs is the source voltage, Ii is the input current, Vi is the input voltage, then Zi is the input resistance or input current impedance without feedback, it is Zi. Okay. Then we have I naught is equal to AVI. Just now we looked at the basic circuit of current series feedback amplifier where A is equal to I naught by Vi or I naught is equal to AVI. I naught is equal to AVI. Okay. Then as it is a current source, the output resistance or output impedance will come in parallel, that is Z0. Then we have the voltage across the load resistance. Then from the output, the current is tapped and it is given as input to the feedback circuit. The output of the feedback circuit is the voltage which is in series with the input. It is in series with the input. Okay. Beta is Vf by I naught. Vf by I naught. That is output is the voltage, input is the current. Output current I naught. Okay. Output impedance is determined. How we are finding the output impedance? What is the procedure? Can anybody tell me? For finding the output impedance, we are shorting the we are turning off the active sources, that is Vs we are making it 0, right? For finding the output side impedance, we are turning off the active source, we are making Vs is equal to 0, and then we are applying the voltage source across the output terminals to find the impedance at the output side. What we are doing, we are turning off the active sources, Vs we are making 0, and we are applying the voltage across the output terminals. RL we are removing, and we are applying the voltage across the output terminals. Okay. By applying signal V to the output with Vs shorted out, resulting in a current I, when we apply the voltage V across the output terminals, then let us assume that the current flowing is I. Current flowing into the circuit is I. So V by I gives the output impedance. Voltage across the output terminals is V. The current which is flowing in at the output terminals is I. Therefore, V by I gives the output impedance. V by I gives the output impedance. Okay. Now with Vs equal to 0, voltage source we have shorted. We have made the active source off. Vs is equal to 0. If Vs is equal to 0, that it is shorted, then how much will be Vi? Vi will be is equal to Vf. Am I right? Vi, this voltage will be equal to Vf because they are in parallel. Is it not? Positive to positive, negative to minus, negative to here positive is connected to negative, but they are in parallel, correct? Therefore, Vi will be equal to Vf. Vi will be equal to Vf. Okay. So as Vi is equal to Vf, as they are connected in parallel, fine. Therefore, we are writing the equation Vi equal to Vf, and I is equal to the current I here, which is flowing across the output terminals, that is given by this current I naught. It is getting split into the current flowing through Z naught and the current flowing into the output terminals, correct? This I naught current which is flowing from the current source, it is getting split into the current flowing through Z naught and part of the current flowing into the output terminals. Now we want, let us say this current is A, this is B, this is C. A is this current, B is the current flowing through Z naught, and C is the current flowing through output terminals. A is equal to B plus C, or C is equal to how much? A minus B. C is equal to A minus B. A is this current I naught, B is the current flowing through Z naught, and C is the current flowing into the output terminals. Therefore, C will be equal to A minus B. But here for the current series feedback amplifier, the value of Z naught is very less. Is in terms of either kilo ohms or ohms, right? It is less, right? Therefore, here as the value of Z naught is very less, therefore what is done here is this current is more than I naught. The current which is flowing through resistance Z naught is more than the current through I naught. Therefore, this current minus this current is taken. Instead of taking I naught minus the current flowing through Z naught, we are taking this current minus this current. Okay, that is V by Z naught. V by Z naught is the current which is flowing through Z naught. V is the voltage across the output terminals. It is V. It is in parallel. Therefore, V by Z naught. V by Z naught is the current flowing here. This current minus this current. This current minus this current is the current which is flowing into the output terminals. That is V by Z naught minus AVI. V by Z naught is this current minus this current. That is I naught. AVI is the current. Okay. So V by Z naught, V by R is I. So minus AVI minus AVI. That is further equal to V by Z naught minus. We have found out that Vi is equal to Vf. Vi is equal to Vf. So V by Z naught minus AVF or V by Z naught minus A. What is Vf? What is Vf? Feedback voltage. See here, Vf is equal to beta into I naught. Vf is equal to beta into I naught or beta into I. If you are taking the output current as I instead of I naught, then Vf will be equal to beta into I. Substitute that, Vf is beta into I. Then what we get here, I is equal to V by Z naught minus A beta I. Take this minus A beta I to the LHS, it will become plus A beta I. Take this minus A beta I to the LHS, it will become plus A beta I. That is I plus A beta I, that is equal to V by Z naught. I plus A beta I is equal to V by Z naught. If we take I common, then we get 1 plus beta inside the brackets. Correct? I into 1 plus A beta or beta A, that is equal to V by z naught. I into 1 plus a beta is equal to v by z naught, or v is equal to z naught into I into 1 plus a beta. What we have done here, this minus a beta I we have taken to the LHS, it will be plus a beta I plus a beta I. What is common? I is common. I into 1 plus a beta, that is equal to v by z naught. Therefore, v is equal to cross multiply z naught into 1 plus a beta into I. V is equal to z naught into 1 plus a beta into I, or V by I. What is output impedance with feedback? Output impedance with feedback is the voltage that we have applied at the output terminals divided by the current that is flowing into the output terminals. That is V by I. Instead of I naught, here we are taking it as I. That is the only difference. That is the only change. Therefore, V by I is the impedance with feedback, that is rearrange the terms, that will be Z naught into 1 plus A beta. Take this I to the RHS, it will become to the denominator, that is Z naught into 1 plus A beta is equal to V by I. But what is V by I? It is ZOF, that is output impedance with feedback, that is equal to Z naught into 1 plus A beta, Z naught into 1 plus A beta. Okay. So this is the derivation of the output impedance with feedback for the current series feedback amplifier. Okay. I hope everybody understood this derivation here. Current series feedback amplifier output impedance derivation. Is it understood? Yes. Is it understood here? Chandrasekhar?
Yes, sir. Clear, sir. Clear all, sir.
Okay, fine. Samir Ahmad? Kaji?
Yes, sir.
Clear with the derivation, Samir Ahmad?
Yes, sir.
Okay. In today's class, we discussed voltage shunt feedback amplifier and the derivation of input impedance of the voltage shunt feedback amplifier. Then we have taken an example where we discussed the voltage series feedback amplifier taking 2 beta values. We have found out the values of gain with feedback, input impedance with feedback, and output impedance with feedback. Then the current series feedback amplifier and its derivation of the output impedance. In examination, they will ask like derive the equation for output impedance of the current series feedback amplifier. Then you have to start from the basic circuit, then draw this circuit, and then derive this equation, and then derive this equation. Okay. If they ask for the voltage shunt feedback amplifier, suppose if they are asking the question on input impedance, then the question may be derive the equation for input impedance with feedback for the voltage shunt feedback amplifier. In this way, the questions are asked on these topics. Okay. Any doubts here, students? Any doubts here? Sagar? Sagar? Sai Prakash?
Yes, sir.
Any doubts, Sai Prakash?
No, sir. No doubt.
Okay. Sanket? Sanket? Shubham? Shubham?
Yes, sir.
Any doubts here? Anything not understood, Shubham?
No, sir. Clear, sir.
Clear? Okay, good. Shraddha? Shraddha? Okay. Atiya? Atiya?
Yes, sir.
Is it clear, Atiya, today's derivations and
Yes,
example?
sir.
Okay,
Yes, sir.
fine. Okay, fine. Then in the next class, we'll take up the next topics, that is in the module 3, second half. Okay, we'll continue with those topics in the next class. Okay, thank you.